Good afternoon, everyone. Thank you for coming. And my name is Honggu Kim and doing master's degree in Yun-Gyung University. Today, I will present CoDi, which is a story generation multi-agent system that can support interactive storytelling system. Let me begin with motivation. Interactive storytelling provides story based on the player's interaction. For example, there is a Detroit Become Human, and this game, based on the player's choice, it gives like different narrative progression and different endings. And for another example, The Sims, players can interact with NPCs in the world and make their own story. The interactive storytelling can provide this like personalized experiences. However, making interactive storytelling is quite difficult because firstly, we cannot predict human players' action, and interacting with players in real time is really labor intensive. Meanwhile, automatic story generation system has studied a lot, and this can be a key to reduce this authoring effort. One major line of the story generation research is plot-based approach. A plot-based approach first generates plot and then expand this plot to full stories. For example, there is a Hollywood. It is a director-actor framework that director agent first generates plot and then actor agents expand this plot by role-playing. Basically, this kind of approach make long and coherent stories. However, they are limited because it just relies on narrowly defined outlines. So it cannot adapt to interactive storytelling system where a player interaction can change the plot progression. And there is another approach. It is rule-based, goal-driven approach. The best example would be Sabre. In Sabre, in the narrative planner, it predicts a sequence of character actions that fulfill both of narrative and character agents. Here is some example. Tom wants to get MacGuffin from merchant. Then Tom can buy MacGuffin from the merchant. However, Tom can steal MacGuffin from merchant. Like this, this can provide higher flexibility in narrative progression than plot-based approach. However, it is rule-based, so it is constrained to predefined story elements. So it is hard to adapt to interactive storytelling system. So our goal is to combine those strengths of related works. And from Harlemwood, we adopt structured director-actor framework, and we adopt from Sabre the flexible goal-driven approach. So we are going to design a multi-agent system called CoDi, which stands for Control Enhanced Director Agent. And our goal is to generate some story generation pipeline that is flexible and controllable, which can be a foundation for interactive storytelling system. Here is the overview of CoDi. We begin with 3 prompts from user. There is some prompt like write about story, something, something, blah, blah. There would be some user's requirement about story. And then after receiving the prompt, through collaboration of planner, character, director, editor agent, we finally get final output, the story. The first stage is story setup. In this stage, planner agent initializes the context for the story. First, planner agent receives story prompt and initializes what we call a story word. In the story word, it contains entities, initial state, and utility functions that is inspired by the Sabre framework. You can see the example of utility. It is a case study. There is the correct canopy jar is restored, and Horus gains meaningful insight into the modern world. The thing is that there is no particular ordered narrative progression, and there is no ending. So the story will be simulated based on the narrative utility. After initializing the story world, the planner agent expands the character entities to character agents. Each character agent has their own profiles and their own utility functions, as the subret did. The utility function will be dynamically changed, updated through the simulation. After the story setup, there is a simulation stage. Director agent simulates the story in a turn-based manner. Every turn, director agent chooses among 3 commands, which are character, intervention, and ending. The first command is character. Director agent can provide performance instruction to specific character. Then the chosen character, by seeing their profile, utility function, and the story context, they generate an output consists of inner thought, action or emotion, and speech. After the character reaction generation, we provide some opportunity to director agent to activate description mode. This description mode is particularly important in this text-based environment. Unlike the video game, we can see the state change visually, right? However, text environment, we should describe the output. So in this example, character agent dived into the flame, and then the director agent decided to make description like destroy of building because of the pressure. The next command is intervention. Director agent can intervene directly into the story and change the narrative progression. Here is some case study for the intervention. There is a utility function that Dr. Nikolai protects Arthur. So director agent decided to introduce undefined character called Arctic Wolf here, and Arctic Wolf blocked their path to introduce threat. So because of that, Nikolai could have the opportunity to protect Arthur coherently. The next case study is introducing new events. There is a utility narrative function that Beowulf is detained by Harris. However, in the story context, since Beowulf was too strong, Harris could not stop Beowulf. So director agent decided to introduce an event because Beowulf did violent actions, allowed power surge, darkened the pub. So there is some opportunity to stop Beowulf in here. The last command is ending. If all narrative goals are fulfilled and all the major events are satisfied, then director agent can terminate the simulation. When director agent ends the simulation, it should declare all of the narrative goals satisfied by some evidence from story progression. The last stage is editing. After the simulation, editor agent can refine the simulation output. First, it reformats the simulation output to specific format like screenplay script. And that it removes inner thoughts of character agent for reducing the redundancy. For example, at the below left side, there is a character dialogue, and after the editing, you can see the right side, there is a scene notation, and you can see that the inner thought is deleted for reducing redundancy. So here is our experimental setting. we adopted an evaluation protocol proposed in Agent Room paper. This paper proposed a data set called Tell Me a Story, which contains 55 story prompts. And it adopted A/B test with LLMs judge, and it has a high alignment with human evaluation. In addition to this, we did also BA test to reduce order bias of LLM judge. For the baselines, we used human set, which is human written references in the data set, and then Hollywood, which was the director actor based framework we talked in the related work. Here is some evaluation metrics. When we compare this to human set, there are 5 metrics from Agent Room. It is plot, development, language use, creativity, and overall. All of them is related to the story quality. And then when we compare this to CoDi to Hollywood, we added 2 more character-centric metrics from Coser paper. It is because we use same story word and same characters. So here is the main result. Blue indicates CoDi wins, and gray means tie, and red means lose. So when we compared our framework to human reference, the results shows competitive or higher performance. Especially the plot metric, we demonstrate the tie rate higher than 60%, which means it generated a comparable plot quality. And then when we compare this to Hollywood, it consistently outperformed Hollywood. And then we also did evaluation study to show the intervention option. As you can see, intervention affected the story quality, and it means that character-driven progression alone is insufficient. We also calculated the goal achievement by LLMs judge framework by Coser paper, and we got 80% of narrative goal achievement. If we delete intervention, it drops to 60%, which means the intervention is really powerful for achieving goal narrative goals. So in conclusion, we present CoDi, and it can be a foundation for interactive storytelling system. However, there are tons of limitations. Firstly, because the director agent plays a strong control role, character autonomy can be reduced. And then secondly, the quality of generated story will be highly affected by the director agent's performance. So we will need to combine something like symbolic methods to reduce the dependency. And then the last limitation is the subjectivity in the design of prompts. We try to read the narrative theory books and papers to design prompts. However, there were some customized prompt design by me. So collaboration with literature and storytelling experts may lead to richer narrative structures. Therefore, for our future work, we should apply this CoDi to actual interactive storytelling system, and then we should do human evaluation with the interactive storytelling. Thank you for listening. Here is a QR code that you can access to our GitHub code. The contradiction between the goal and then the character actions outcome, right, like that. In that case, it is also limitation, but there is nothing that check the contradiction between the outcome and narrative goal. The director agent just make delay to make another intervention or another character chosen to fulfill the narrative goal. The both happens. Um, I think may I didn't understand. Can we talk in the coffee talk? Sorry. Yes. Yes. So because we make like if director agent generates some response contradict the current state, because director agent here is large language model, so it there is no other rule-based constraint in this framework. So director agent can produce redundant or the response that contradicts to the constraint of state. So it is one of the limitation. Yep. Yeah. Yes. Uh, the character fidelity means that it is checking whether there is a character profile and character acts based on the profile. However, it is does the character act consistently with the profile? Is checking the metric. Yeah.